Welcome back to the new class. Now today I am going to discuss function. This is in the chapter mathematical tool. A function is a relation between a set input values x and a corresponding set of permissible output values y such that each input is related to exactly to one output. Therefore, if y is a function of x, then we can write as y equals to f(x). So I am giving an example here. If a variable quantity y varies with the quantity x square, then we can say y equals to x square. This is here the meaning of the function. Then we are moving towards limit. So in the limit, if f be a function defined on the some open interval that contains the number a except possible at a itself, then we say that the limit of fx as x approaches to a is L, and we write limit x tends to a function of x, this will be equals to L. If for every number epsilon naught is greater than 0, there exists a corresponding number delta is greater than 0, such that function of x fx minus L, this will be less than epsilon. Wherever 0 is less than x minus a and it is less than delta. I think you understand here. So in other words, we can say that a limit is a value towards which an expression y converges as variable x on which y depends approaches certain values x. Now I am going to discuss here one example. So we are going to find out limit of x square minus 1 by x minus 1, where x tends to 1. This may be written as limit x tends to 1 x plus 1 into x minus 1 by x minus 1. This equals to limit x tends to 0, x tends to 1, and here this will be cancelled, then x plus 1. Now taking the limit, putting the value of x 1, then 1 plus 1 equals to 0. This is here the one example, and I am going to discuss now here quite new thing for you, that is the differentiation. This is a very important tool in our calculations. Differentiation. Differentiation. So first of all, we should know here about the differentiation. The derivative or differential coefficient of a dependent variable y with respect to an independent variable x is defined as the ratio of the change in the variable y corresponding to change in variable x when the change in x approaches to 0. So mathematically we can write y equals to fx at a number x, and we can say here differentiation of y, this is dy by dx. This can be written as limit where delta x tends to 0. Delta x tends to 0, and this can be written as delta y by delta x. Delta x and delta y is the small changes in their respective, means delta x changes in x and delta y changes in y. So this can be written as here limit delta x tends to 0, and this is equals to f x plus delta x minus function of x, this by delta x. So if this limit exists here, now we are going to derive it. Let y is a function of x. So y equals to fx, and delta x is the small change in x and delta y is the corresponding change in y. Then this equation can be modified like that here. This is the equation number 1 and this is the equation number 2. Now subtracting equation 1 from 2, this from this here. So y plus delta y minus y equals to f x plus delta x minus fx. This will be equals to delta y, this is f x plus delta x minus f x. Now dividing both sides by delta x. So delta y by delta x is equals to f x plus delta x minus f x by delta x, and this is equals to dy by dt. So taking the limit when delta x approaches to 0. So here taking the limit delta x tends to 0, then delta y by delta x is equals to this is, and we know here this equals to dy. So dy by dx, this equals to this. I think you understand this very well. So after that, we will meet in the next class. Thank you very much.